Now we're getting into chapter 28, practical position measurement. Once again, in this chapter, there's not a whole lot of content. We're going to use a lot more of content in the actual labs, but we're using a discussion of ranges. So sensing range becomes very, very important. The idea of that certain sensors work better in certain ranges, and you need to select the range of the sensor before, say, it senses an object and turns on. The distance is very, very important. We also have key terms like actuation direction, because obviously if you've got a limit switch, it's got a lever, you need to approach that lever from that direction for it to actuate. And so sometimes if you're coming to a sensor and then retreating from a sensor, it turns on at a different distance than when it might turn back off again as you retreat away from that sensor. So that range, that distance between where it turns on, it turns off, is called hysteresis. There's that same term that we used before. And so the book talks about some mounting characteristics and how you would mount it so that you can have the correct characteristics used. Rotary speed sensing is a critical deal. I once installed an inductive sensor in an application where it was measuring it was counting the teeth of a sprocket as it went around. And what I found is it couldn't count fast enough because the sensor wasn't quick enough. So I needed to get a sensor that had a faster speed capability instead of the sensor that I used. So, and they show various methods of calculating the frequency based on, the sprocket. You might have so many teeth per rotation. You should be able to, based on the number of pulses per second, figure out the RPM. They show a couple ways of mounting these. And they show different applications for doing the mounting. And one really good application is called the safety light curtain. We've got one of those up in Harrisburg, which I'm going to steal. We're going to put into our robotics room. Don't tell those guys I'm going to do that. But basically the idea is you have a whole series of light sensors in a row. If you break any one of them, it causes a signal to be sent to your, in this case, robot, that'll shut that robot down. And that's it. So this is just sort of a mishmash in terms of material. Our actual lab's going to be a little bit better.